Okay, so what we're trying to do in this lesson, we're going to look at Theorem 1. And basically what this theorem says is that the angle opposite the longer of two sides is greater than the angle opposite the shorter side. So let's identify the sides. So this is the longest side. So from A to C is the longest side. And from A to B is the shortest side. So basically what this theorem is trying to say is the angle opposite the longest side. So this is the angle opposite the longest side. This angle is going to be greater than the angle opposite the shortest side. Here's the shortest side, here's the angle. So what we're trying to prove is the angle. So basically this is what we're trying to prove. We're trying to prove that the angle ABC, so A, B, C. So we're trying to prove that this angle, so A, B, C, notice we have 3 points, so the point A, point B, and point C, and notice that the angle is on point B. Okay, so we're trying to prove that this angle is bigger than this angle, A, C, B. So that's what we're trying to prove this. And a proof basically, or a theorem, is basically a structured way or a logical way at proving that something is the way that it is. In this case, we're trying to show that this angle is bigger than this angle. So the first thing we want to do, the first kind of construction, if you like, so construction, and we'll just put this over here. Maybe we can actually put it over. Let me get rid of this and we'll put it over here. So we'll get rid of that. So we have our construction. So basically what we want to do is the line AB, so the line AB, so it has a certain length. Now what we want to do is we want to, let's say, draw a point on the line AC so that it's equal to the length of AB. So imagine, so let's say it might be somewhere, or let's say around here. So we're drawing a point, and let's call this the point D. Okay, so we're drawing this point, or we're placing this point on the longest side. Now, I'm just kind of eyeballing it, but basically this would be, so what you're doing is you're making it so that this length here from A to D is going to be equal to the length from A to B. So you're creating a line that's equal to AB, and we're calling that line AD in this case. Okay, so it's just a hair. And then what we want to do is we want to draw a line, so we want to connect point B to point D. So I can use my ruler here to do that. So let me just mess around with this. So let's get it around here. Okay, so we want to connect these 2 points here. So let's say roughly about there. So I might draw this line just in a different color so that it kind of stands out. Okay, maybe we need to push this up as a fraction. Okay, so I think that's more like it. So we're drawing our line. So just connecting these 2 points here. Okay, nice simple line. Well, let's get rid of the ruler. And what we can start to do now is we can start to number these angles. Now, before we do that, just a couple of things that we notice. So we can draw, I can draw 2 dashes across this line and 2 dashes across this line. So all that means is that the line AB is equal in length to the line AD. And then what we can do is we can name these angles. So we can call this angle 1. And if this length is equal to this length, then this is an isosceles triangle. And in isosceles triangles, the base angles, which is going to be this one and then this guy here, will be equal to each other. So we can say that 1, and we'll call this the angle 2, 1 and 2, the angle 1 and 2 are equal to each other. So we can say that the angle 1 is equal to the angle 2. And then we'll name these angles down here. So we'll call this angle 4, and we'll call this angle 5. And what we can say here about these angles here, so angle 2, which is an exterior angle, so the angle 2 is greater than the angle 4. So this is greater than the angle 4. Okay, so exterior angles, which this is an exterior angle, are greater than interior angles. And we can call this is our proof. So what else can we say from this? So for example, if angle 2 is greater than angle 4, then it only, and if angle 2 and angle 1 are equal to each other, then it must, from that, we can derive that angle 1 is also greater than angle 4. So we can say that angle 1 is also greater than angle 4, like so. So already we've shown that like only part of this angle over here is even bigger than this angle here. So what we can say that, so angle 1 and angle 2 are equal to each other, and angle 2 is greater than angle 4, and angle 1 is also greater than angle 4. So therefore angle 1 and angle 5, which is this angle down here, so it goes without saying then that angle 1 plus angle 5 are going to be greater than angle 4. And this is kind of like what we've been trying to prove. Now I just said angle 1, angle 2, angle 4 and angle 5. Okay, so it doesn't matter what numbers you put on the angles, you're just using them as labels to identify the angles. So what we're trying to prove here basically, and we've kind of proved it here, so what we're saying then, so we can just finish this out and say that the angle ABC, so that's the angle ABC, is bigger than the angle ACB. We can say that that's bigger, and that's essentially this theorem, and this is what we're trying to prove. So if angle 2 on its own is bigger than angle 4, then an angle 1 is equal to angle 2, then it goes without saying that just angle 1 on its own is going to be greater than angle 4. But this overall angle here, ABC, has this angle 1 and angle 5. So when we add them together, it's even going to be it's going to be definitely way bigger than this angle here. And that's essentially what this theorem is trying to prove, very, very simply. So all you're saying is that the angle opposite the longer of two sides, so the angle opposite the so this is the longest side, so A to C, and the angle opposite the longest side is bigger than the angle opposite the shortest side. So this is the shortest side, and this is the angle opposite the shortest side. So what we're saying is that this angle in here, this like as in, so it's made up of angle 1 and angle 5, is bigger than angle 4. And that's what this theorem is basically proving. and we're just going through it in a logical fashion. So basically, all we are doing is, so our construction basically is, so we take our triangle, we find a point on the longest side that creates a line that is the same length as the shortest side. Okay, so that's so A to D, the length from A to D will be equal to the length from A to B. Then all you do is you just connect the line B to the line D, and essentially what this does is it cuts the angle opposite the longest side into two angles. And then what we can say is then that this angle here, which is an exterior angle, is going to be bigger than this angle here, which is an interior angle. And then from there, then we can prove that, so this angle is equal to this angle because this here forms an isosceles triangle. These two sides are equal. And if let's say this angle then has to be equal to this angle. So these will be equal to each other. And one of these angles on its own is bigger than this angle opposite the shortest side. So therefore, the angle opposite the longest side is actually made up of these two angles, which one of them, this one on its own, is bigger than this guy. So therefore, if we add this guy in, it's definitely bigger. And this is just a formal way of proving this idea that if you take a triangle like this, the angle opposite the longest side is going to be bigger than the angle opposite the shortest side. And that's really it. Nothing more complicated than that.